All right. So 5-1 is all about solving proportions. So let's start by defining what a proportion even is. Let everybody know before I tell you. Any guesses? Proportion? You've heard the word before, right? You've probably heard like proportional. So proportion, what does that mean? If I say that something is proportional? Or it might be easier to understand what out of proportion is. I'll give you an example of out of proportion. You ever go to a carnival or something and go into one of those house of mirrors? They got some mirrors that make you look like you're 10 feet tall. You're out of proportion, right? It stretches distorts what you look like. Okay, so proportion is everything keeping, like if I were to take a photograph and I wanted to enlarge that photograph, I want the bigger photograph to look just like the original, just bigger. I don't only want to stretch it because then everything's going to get really narrow and distorted. I want to keep it in proportion. Okay, so in math, how we make sure that those proportions are kept, proportions are just two fractions that are equal to each other. So if I know what the original dimensions are and I know, okay, I want to increase this and I want my new photograph to be, I don't know, 10 inches wide instead of 4 inches wide, I need to figure out what the length should be to match that. Okay, so proportions are two fractions that are equal. That's all a proportion is. And we can use proportions to find all sorts of good information. Out of all the topics that we do, I think this unit 5 is probably one of the most that you're going to actually use in everyday life. So yeah, this whole unit is we're doing proportions, scale models, percents. Yeah, so this is probably one of our most useful chapters in everyday life, in my opinion. All right, so let's talk about some properties of proportions. If I took two fractions that really are equal to each other, like 1/2 and 4/8, aren't those really equal to each other, right? 1/2 and 4/8, same thing. Just one is reduced and one's not. Are you aware that if you multiply the diagonals, look what happens? Give it a go. If you multiply the two diagonals with each other, so in other words, if you multiply the 1 and the 8 together and the 2 and the 4, what do you get? Yeah, you get 8 both times. When I multiply these two, I get 8. When I multiply these two, I get 8. You think that's a fluke or is that always going to happen? I don't know. Let's try another proportion. Let me try something like, how about 3/5 and 6/10? Those really are the same fraction. If I reduce 6/10, I get 3/5. So these are two fractions that are equal to each other. Try that same thing with multiplying the diagonals. Are they really still equal to each other? Oh, it happens every time. Every time. I get 30 on this side, I get 30 on this side. So the fact that that's always going to happen lets us solve proportions using that same idea. So this is an important thing. When you multiply the diagonals, you will always get the same number in a proportion. Because if I have just two random fractions and I multiply the diagonals, there's no guarantee that those are going to work. But if I have a true proportion, so two fractions that really are equal to each other, if you multiply the diagonals, they will always, always, always be the same, which is kind of a nice thing to know, because if I had two fractions and I wanted to know if they formed a proportion or not, the quickest way for me to do that is to just multiply those diagonals and see if I get the same number. If I do, then yeah, they're proportional. If they're not, then nope. Okay, so let's go back to that photograph. Let's say we have a picture, it's 4x6, pretty standard photo size, but I want to enlarge it. I got a nice new frame and I want to get a new picture that matches. So if my original, let's say, is 4x6, so I can write that as a fraction. But now, let's say my new frame, the short side is, oh, I don't know. Let's say it's 12 inches across. And I want to figure out, okay, well, what should my new length be then? If the new width I want it to be 12, how long should it be so that the photograph stays in proportion? It looks exactly the same as the photograph before, it's just bigger. I didn't stretch it or squish it. So what I can do is I can take this and I can find the number that's going to complete the proportion, doing this cross multiplying. You ready? So check this out. All I have to do to solve for this missing number, I'm still going to multiply my diagonals. It doesn't matter which diagonal you multiply together first. Doesn't matter. So let me give some step-by-steps at the same time. To solve a proportion, multiply the diagonals. Oops. So on one side, if I do 12 times 6, that's, I don't even know. 72. What do you get when you multiply 4 and x together? 4x. So all I do is I set those two equal to each other. So that's step 2. Set the answers equal to each other. And now I just have this equation that I can solve like we have been. So all I'd have to do to figure out what x is how would I, this is my equation, 72 equals 4x. How do you solve that? Divide by 4, right? I want to get that by itself, so let's divide by 4, and I'll just check what 72 divided by 4 is, 18. So that means 18 is the number that's missing there. That's the number that would make that proportion. I could check it real quick. If I do 4 times 18, it should get me 72, right? Because I multiply both diagonals. So let me just check. 4 times 18, yep, 72. So go back to the example that we were talking about in the beginning. If I had a 4x6 photograph and I wanted to enlarge it so that the new width was 12 inches, that means the length would have to be 18 in order to keep everything in proportion, not cropping anything out, not stretching or distorting the image. Everything is the same, just enlarged. Does that make sense? Everybody with me? Okay, cool. So step 3, once you set them equal, then you solve the equation. And that's really it. I'm going to give you a couple to try because they do get a little bit complicated. So let's try some of the easy ones first, and then we'll step it up and try some of the tougher ones. Does everybody have what they need here? Because I got to flip the page. By the way, they don't always come out as nice numbers, so you can get decimals, whatever. Oh, good news is I'm pretty sure you can use a calculator for this whole chapter. So if you want to use a calculator, feel free. Let's do, how about 10 over x equals 4, no, never mind. I'm going to make that 15 over 6. That one I think comes out nice, I think. Yes, it does. Let me give you some that might not come out nice. You can also have negatives, so I'll throw in some negatives here. All right, try these 4. So multiply those diagonals. Write it as an equation, and then solve that equation. Okay, let's see how we did. Number 1. Christian, what'd you get for number 1? Not quite. So first thing I want to do is multiply those diagonals. So I'm going to do, and it doesn't matter which diagonal you do first. Doesn't matter. So if I do 10 times 6, what's that? 60. So there's one of my answers. And then on the other side, what's 15 times x? 15x, right? So you just take those two answers and you write them.
4.
It is 4, right? I have this equation now. So see how I put that equal sign? A lot of times kids mess this step up. They try and write, they get the two answers and then they write it as a fraction. But that's not a thing. It's an equation where it's equal to each other. See how that works? And now I solved that equation by dividing both sides by 15. So Christian is correct with 4 as a final answer. Okay, that one came out nice. I don't think that they all come out nice. I don't think the next one does, but it's not that bad. All right, so number 2, J with an E, what'd you get?
I think I asked those because I thought X as like 980, I think.
I think this one is a decimal. So let's see. What is 7 times 4? 28. And then x times 3 gets you 3x. So you're going to divide both sides by 3. And 28 divided by 3. 28 divided by 3. Yes, you're spot on. 9.3 repeating. So they can come out as decimals, and that's fine. By the way, you could have left it as 28 over 3, right, as the fraction. So if you left it like that, that's okay too. All right, let's try the third one. I don't think this one comes out nice either. So this one probably has a decimal as well. Ash, what'd you get on the third one? Let's do it together. What do you get when you multiply 3 times x? 3x. So I'm going to set that equal to. Now I'm going to do negative 2 times 8. What's that? Yes. And then what do I do? Yep, just divide both sides by 3. So whatever that comes out as, you could leave it as negative 16 over 3. Or if you have a calculator and you actually divide them, looks like negative 3.2. Oh, sorry. Okay, so yes, you can leave it as a fraction as long as that fraction is reduced. But that one's fine. Number 4, I think, is nice. What did you get? A number 4, J with no E.
20.
You are correct. Multiply those diagonals, right? So be careful right here, everybody. If I do negative 1 times x, that's negative 1x or negative x. On the other side, 5 times a negative 4, that's negative 20. So now you're here, but you need positive x, right? So we have to divide both sides by negative 1. And that's how I get a positive 20 as my answer. Is that okay so far? All right, now I mentioned it does get trickier than this. Sometimes.
Please find the interruption. Elise River to the cafeteria. Elise River to the cafeteria, please.
So I'm going to put a big star on these harder ones. And my big reminder is don't forget to distribute. So sometimes you'll get a problem that looks like this. Something like x plus 2 over 5 equals, I don't know, 8/15. Let's do that. The process is still the same. I'm still going to multiply the diagonals, but something weird happens, right? When I multiply these diagonals, okay, cool, that's 40. That's no big deal. But when you multiply these diagonals, this is a really, 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 really big deal. So everybody watch. You have to do 15 times this whole thing. So you have to do 15 times x plus 2, like that. So in other words, you need to do 15 times x and times 2. All of it has to get multiplied by 15. So I'm really going to be distributing that. So that's what I mean with my big reminder. Don't forget to distribute. So that looks like this. 40 equals 15x, and then 15 times 2 is just 30. And now I have an equation that I can solve just like I did before. So can someone remind me, what would I do to solve this equation now from here? Exactly. I'm going to minus 30. Now it just becomes like a normal problem like we did last chapter, right? So I get 10, 15x, and then my last step would be to divide by 15. So this one, 10/15 is 2/3, right? If you reduce by 5. So there's my answer. But you got to be super careful, because I'm telling you right now, a lot of kids are going to forget to distribute. They'll do the 15x, but then they won't remember to multiply the 15 by the 2 also. All right, so let me give you one to try. Then I'll give you a whole bunch to try probably. Let's do, I'll try and find one that comes out nice. How about, oh, that one's good. All right, let's do this. All right, try that one. At least I think that's nice. Yeah, it is. Yeah, okay. So try that one. Multiply your 2 diagonals. Doesn't matter which diagonal you multiply together first. Just be sure that when you're doing the 3 times x plus 2, you distribute. Okay, did you get an answer? That's a nice number? Yeah? Maddie, what'd you get? 22. Anybody else get 22? Good. Yes, 22 is the right answer. So let's see how you arrive at that if you didn't get it. Multiply one diagonal, multiply another. Okay, 6 times 12, that is 72, right?
Aren't you gonna do like 3x plus 2x?
Yeah, so on this side, I'm gonna do 3 times x plus 2. It doesn't matter which side you put the 3 and the x plus 2 on, right? So if you have it flopped over and you have 72 there, it doesn't matter. So now I gotta distribute that 3. So let's do 3 times x and 3 times 2. 3x plus 6. So if you did this problem out, please make sure that somewhere you have 3x plus 6 equals 72. If you don't, then you did not distribute. Now, where do I go from there? Yes, now I minus 6. So that's 56. Is that right?
6.
Thank you. Just testing you. There we go. And now all I have to do is divide by 3. And that's where the 22 comes from. How do we feel? Does that make sense? Yeah? So let me give you a couple that are just sort of a mixed bag, some easy ones, some trickier ones. And that'll probably be as far as we get before lunch. So let me flip. Let's try these. How about? Ooh, I just thought of another type of problem. What if you had like a 2x over 5 equals, I don't know, something like 3 over. Try that. I mean, you do it the same way. Wow, what about that? I'm gonna give you a challenge problem over on this side. Number 4. Yeah, let's call number 4 challenge. Oh, I like that one. Yes. I think they might all be decimals. Maybe not the last one. I don't actually know the answers to that.
It's the first one, 3 repeated. 3.3 repeated.
Yep. Is lunch like 20 or 25?
24.
24? I think I know by now. Okay, we got some answers? Let's see where we're at. Number 1, what did you get, Connor? Number 1, I would like your answer, please. Yeah, and then what do you get? Say it again, sorry. You can, I mean, you're not wrong, but it's not gonna help you get to your final answer. From here, can't you just divide both sides by 6? So 20/6 is your answer. That does reduce to be 10/3. So you could either give 10/3, or if you turn that into a decimal, I believe that's 3.3 repeating. Okay, so there's number 1. Number 2, what did you get? Noah? Okay, so let's multiply this diagonal. 3 times 8 is 24. On the other side, you got to do 9 times all of x plus 1. Hold on. So you got to do 9 times x. What's that? 9x. And you got to do 9 times 1. Yeah, so now you have this equation to solve. 24 equals 9x plus 9. Right here. So what would I do to solve for x now? What's my next step? That's a plus already. Yeah, minus 9 from both sides. So 24 minus 9 is 15. So now we are at 15 equals 9x, and all I have left to do is divide by 9. So whatever 15 divided by 9 is, I got 1.6 repeated. Number 2, this was, yeah.
Yeah.
Okay, and let's see if we can get to number 3 before the bell. John, what'd you get on 3? Let's go back. So if you multiply 6 times 5, what's that? I thought it might be. What's 6 times 5? 30. What do you get when you multiply 18 times negative x? What would that be? Yeah, negative 18x, right? And then all you have to do to get x by itself is divide both sides by negative 18. So whatever 30 divided by negative 18 is, I got a negative 1.6 repeating. That's weird. Same answer as the last one, just negative. And we will, we can do 4 right now. Does everybody think they have an answer to 4? That's right. What'd you get?
Is it 1.8?
1.8. I don't actually know what the answer is, so maybe. Anybody else get another answer? All right, let's see. So I'm going to multiply my diagonals. 4 times x is 4x. On the other side, I have to do 12 times all of that, 2x plus 3. So I have to distribute. So I'll get 4x, 12 times, oh, never mind. I'll tell you after lunch. All right. So we had already multiplied the diagonals. And so now I'm up to the part where I'm going to distribute that 12, right? So 12 times 2x gets me 24x. And then 12 times 3 is 36. So now this is one of those situations where we have x's on both sides, but we know how to solve this. I would probably minus 24x from both sides. I know that's going to give me a negative x, but remember, I'm trying to get, I'll have one less thing over on this side. So I'm going to do it that way, minus 24x from both sides. So that leaves me with a negative 20x equals 36. And then all I have to do is divide by negative 20. So my answer would be whatever 36 divided by negative 20 is, and I get a negative 1.8. Oh, Jay, you were so close. All right, thoughts? We're okay here? Easy peasy, maybe? So the only other thing we have to talk about is conversions. How do I want to do this though? I don't have a clue about this. Well, see, I don't do it. No, I wouldn't do these. I don't really do them with proportions. Maybe, okay, maybe before we get to conversions, let's just practice what we have. And then we'll come back to that because I'm not sure if I want to do it one way or another. All right, so let me give you this. Oh. Hello, Ms. Sabia. Okay. All right, thank you. Bye. All right. So let me give you this. We'll talk about conversions in a little bit. So could you guys please try 1 through 17 odds? Okay, try those. I'll give you about 10 minutes or so, 15 minutes maybe, and then we'll come back and see where you're at. You are welcome to use a calculator on this section. You need to borrow one there on the cart all the way on the side. Okay, so let's go over the answers to 1 to 17 odd. So the paper that I just gave you, just set that aside for a minute. Let's get these answers here. Okay, number 1. What did you get on number 1? Francisco, what'd you get? 2 is correct. Multiply those diagonals. You should have 14 equals 7a. Divide by 7, you get 2. Hooray. All right, number 3. What did you get? Sophie. 15 is correct. 9 times 5 is 45 equals 3b. So you should have 15. Perfect. All right, number 5. In the middle here. Maddie, what'd you get? 5. You are correct. That's 63 equals 9y. Divide by that 9, and that's how we arrive at 7. Okay, cool. Number 7. Natalie's not here. Sue, what'd you get on 7?
7?
Yep.
Is it 12?
I don't know if the, yeah, I think you're right. That would be 60, 96. 96 divided by 8, you say it's 12? Yep, you're right. Okay, and then the last of the easier ones, number 9. What is your answer? Oh, I just called on you, Sophie. I got them all mixed up. Someone tell me, what'd you get for 9?
64.
64? Sounds good to me. So we're gonna get when we multiply these two, that's 192 equals 3g divided by 3. Yep, 64 is correct. Okay, now for the second chunk. Oh, 11's not bad either. It has a decimal in it, but so what? You're still gonna do it the same way that you always would. You're all kind of back in the mix again. So let's see who gets to go first this round. Connor. You did. It was, to be fair, it was Natalie first, but she's not here, so I had to switch. All right, what did you get on 11, Connor?
0.5.
I believe that's right. Uh-oh. Hi, it's Miss Sabia. Sure. Thank you. Bye.
No, we can't hear that far, right? Like it's not like loud.
Yes. What if, okay, we're gonna do the conversions at the bottom. So, you know, I'll post the video when we're done. Look to Jupiter for what I end up assigning. And yeah. All right, where were we? Oh, you had said it was 0.5. I think you're right. So, oh, you guys. I don't understand how you guys could not like art. It's so relaxing.
No, the teacher's not very nice.
Well, but still, so just do your art though. I don't know. It just, oh, I love art.
I mean, don't get me wrong, art's great. The class itself with
No.
the specific teacher, no.
Well, are the kids doing what they're supposed to be?
I don't know. I
Yeah,
don't pay attention to
well,
anything but my table.
it gets hard. Anyway, 13. Now we're in the spot where we have, by the way, this is called a binomial. When you have 2 terms like that, instead of it just being one number, there's 2 of them. So anytime I have one of these binomials, that's when I'm gonna have to distribute. So I'm gonna have to multiply both. So what was the answer that you got? Sue,
Which one?
13.
I don't know. Skip that one.
Well, let's do it together. So I already multiplied the sides for you. 4 times 3 is 12. And then when you do this side, you have to do 2 times x plus 2, distribute the whole thing. So on the right-hand side, what does that get you? When you do 2 times x plus 2, what is that really?
X plus 4.
Yes. And then what am I supposed to do? Yeah, I want a -4 from both sides. So now I get 8 equals 2x, and then so what do I do now?
Divide.
Yes, good. So my final answer is 4. So everybody double check your answer to 13. You should have gotten a +4 there. All right, 15. Another one with that binomial, that 2-term thing. So that's how you know you're gonna have to distribute. So Ash, what did you get on 15?
I got 7.
Okay, I don't have the answers in front of me, so you might be right. Let's see. 7 times 10 is 70. And then on the other side, I'll be doing 7 times b plus 3. Oh, sorry, move it off. There we go. Let's distribute that 7. That'll be at 21, right? Minus the 21. Oh, 70 minus 21, what is that? 49. And then divided by 7. You said 7, right?
Mhm.
Perfect. Good job. Okay, double check your answer for 15 should be 7. And then the last of these weird binomial ones, number 17. What is your answer? John, what'd you get there? 3. 17 of them. Okay, I don't know the answer, so I'm gonna do it out and see if I get what you got. One side I get 12z. The other side, I'm gonna have to distribute, right? I'll have to do 4 times z plus 6. So let's distribute on that side. 12z, 4z plus 24. I have variables on both sides. So let's minus 4z to get them together. So now I get 8z equals 24, and I think you said 3, right? And you are correct. That was a tough one because you had 2 things going on. You had to distribute, and then once you made your equation, you had variables on both sides. So if you got that one correct, good job on 17. Okay, now if you take a look at the sheet that I just gave you, this is the reference sheet that when you do go to take the MCAS, this is what they give you. At least this is what they have given in years past. It's subject to change. So there are certain formulas that they'll give you, so you don't need to memorize any of these things. But what I wanted to draw our attention to is this top section. We're going to use some of these conversions. So if I want to change something from, feet to inches, or feet to miles, or ounces to gallons, quarts to gallons, any of those things, they're called conversions. So if I want to switch between my units, that's what I'm doing here. Okay, so this is a sheet that they give you on the MCAS, so you can see what information is there for you before you take it. So let's go ahead and try one of these problems at the bottom. So in the first one, number 19, you want to change 5 pounds into ounces. So all we need is to know, okay, well, how many pounds are in, or how many ounces are in a pound, or vice versa. That's where this chart's going to come in. So if we look, what are we doing? Pounds and ounces. So if you look, try and find pounds and ounces. Oh, here it is, all the way over here. See it? 1 pound is 16 ounces. See that? So what I'm going to do is I'm going to set myself up a proportion to solve this. So check this out. Once I have the equivalency, 1 pound, 16 ounces, I can come over here and I can write it as a fraction. 1 pound is the same thing as 16 ounces. All I have to do to solve this problem, I'm going to set this equal to, thank you. They're saying, hey, 5 pounds is how many ounces, right? So here's what you do. Everybody ready? I want to match up my units. So I had pounds in the top, so I'm going to put pounds on the top here. So I'd put 5 pounds here. And I don't know how many ounces it is, right? That's what I'm trying to find. So I would just put in X. See how that works? So now I have a proportion just like I had on the top of the paper. So now I can just go ahead and cross multiply. Oh, sorry, I didn't realize it was so blurry. The most important thing though is that you match whatever unit is there, make sure it's there, right? So your units have to be in the same spots. So now when I cross multiply, one side I just get 1 times X or X. And on the other side, I have 16 times 5, which is 80. Yep. So there's my answer, 80 ounces. Is that neat? So let's try, I know you probably already, you know in your head the conversion between feet and inches. But let's say, so how many feet are in an inch, or how many inches are in a foot? I mean, 12, right? So 12 inches are in 1 foot. I don't even need to look at the chart because we know this one. So I just set that equal to, and then here's what's important, 7 feet. So where should I put 7 feet, on the top or the bottom? The bottom, because I got to match it up. 7 feet, and I don't know how many inches it is. That's what I'm going to find. So I'm just putting the units in the same spot. Whatever's on top, I match it on the other side. Okay, and then I can cross multiply. 12 times 7, I get 84. So X equals 84, and my units are inches. Oops, sorry. All right, you tried 23, 6 quarts to a gallon. So if you look at the chart, try and find the quarts and the gallons. Oh, I found it. See if you can find it. So look on this chart for quarts and gallons. You found them? Try the whole problem. Once you, it's right here, if you didn't find it yet. 1 gallon is 4 quarts. So you can write that as a fraction, 1 gallon over 4 quarts, and then just match it on the other side. I have no idea. I'm not sure. Let's try. So 1 gallon is 4 quarts, right? So when you do it on the other side, where are you going to put 6 quarts? On the bottom, right? So, because you got to match them. So 6 quarts goes down here. I don't know how many gallons, so that's going to be an X. So it's not 24. It's going to be some decimal. I got to figure that out. So 1 times 6 is 6. 4 times X is 4X. And then I'm going to go ahead and divide both sides by 4. Does that make sense? So I think that's 1.5. 1.5, yeah. And I'm finding gallons, right? So that's gallons. So in other words, 6 quarts is 1.5 gallons. All right, so there is one more that I want you to add to this chart that I'm not sure why they don't give it to you. I don't know if they just assume that you know it. It's probably because it's just the metric. Centimeters and meters. How many centimeters are in 1 meter? 100. Centi means 100, like a century is 100 years. So if you want to add this one, 1 meter equals 100 centimeters. Okay, so I think for homework, let's do Oh, I thought there was. kilograms, here's kilograms.
So there's kilograms of pounds.
Oh, okay, let's add that then. There would be 1,000. Oh, am I right? 1,000 grams in a kilogram, right? I'm pretty positive. 1,000 kilograms. No, 1,000 grams in a kilogram. Sorry. 1 kilogram. I thought that one was on there, sorry. Okay, so for homework, let's do the rest of the problems on that sheet that we haven't done yet. So the evens on the top and then, oh, I guess evens on the whole page. That's funny. I didn't do that on purpose. Okay. Okay, so tomorrow we'll practice some more with conversions and see what else we have in store for us.
Your face when I say 20 people. Stop.